Knob and tube wiring with fuses in both the neutral and live wires was a common practice in older homes and buildings. It is even sometimes seen today. The fuses were there to protect the circuit from overloads and short circuits. Often, people would replace a 15-amp fuse with a 30-amp fuse, or even use a penny to increase the current capacity of the circuit. This was a very dangerous practice. Doing so could lead to overheating and fires. Luckily, most homes and buildings today have updated electrical systems that use circuit breakers instead of fuses. Circuit breakers are safer and more reliable than fuses. They also prevent the use of pennies or other objects to increase the current capacity of the circuit. Older electrical systems were not as heavily loaded as they are today. The appliances and devices used back then were not as powerful or as numerous. This decreased the likelihood of electrical failure. Electrical systems have evolved significantly over time. Early electrical systems, such as knob and tube wiring, relied on fuses for overcurrent protection. Fuses are essentially sacrificial devices containing a metal strip that melts and breaks the circuit when the current exceeds a certain level. The amperage rating of a fuse indicates the maximum current it can safely handle before blowing. The dangers of replacing a fuse with one of a higher amperage or bypassing it altogether, as with the penny, cannot be overstated. Overcurrent protection is a fundamental safety feature in any electrical system. It is designed to prevent wires from overheating due to excessive current flow. When a circuit is overloaded, meaning it draws more current than it is designed to handle, the wires can become hot enough to ignite nearby combustible materials, leading to a fire. A properly sized fuse or circuit breaker will interrupt the circuit before this happens. The consequences of bypassing or upsizing fuses can be severe. The electrical wiring in a home is sized to carry a specific amount of current safely. If a fuse is replaced with a higher amperage fuse, the wiring can be subjected to currents beyond its capacity. This can cause the insulation to melt, leading to short circuits and fires. The use of a penny or other conductive material to bypass a fuse is even more dangerous, as it eliminates overcurrent protection entirely. Modern electrical systems use circuit breakers instead of fuses. Circuit breakers are more reliable and offer several advantages. One is that they can be reset after tripping, whereas fuses must be replaced. Circuit breakers also provide more precise overcurrent protection and are less prone to nuisance tripping. Additionally, many modern circuit breakers offer ground fault protection, which can help prevent electrical shocks. The electrical codes, such as the National Electrical Code, or NEC, specify the requirements for overcurrent protection in electrical systems. These codes dictate the types and sizes of fuses or circuit breakers that must be used in various applications. Adhering to these codes is essential for ensuring the safety of electrical installations. Electrical safety is a critical aspect of home ownership and maintenance. It is important to be aware of the potential hazards associated with electrical systems and to take steps to mitigate those risks. This includes ensuring that all electrical work is performed by a qualified electrician, using properly sized fuses or circuit breakers, and avoiding overloading circuits. Regular inspections of electrical systems can help identify potential problems before they become serious. The dangers of tampering with fuses or circuit breakers cannot be emphasized enough. Doing so can create a serious fire hazard and put lives at risk. If you are unsure about any aspect of your electrical system, it is always best to consult a qualified electrician. They can assess the situation and recommend the appropriate course of action. Upgrading an older electrical system with modern circuit breakers is a worthwhile investment in safety. It can provide peace of mind knowing that your home is protected from electrical fires and other hazards. Circuit breakers offer more reliable and precise overcurrent protection than fuses. They also eliminate the temptation to bypass or upsize fuses, which is a common cause of electrical fires. Ground fault circuit interrupters, or GFCIs, are another important safety device. GFCIs are designed to protect people from electrical shocks by detecting ground faults and quickly interrupting the circuit. GFCIs are required in areas where water is present, such as bathrooms, kitchens, and outdoor outlets. Arc fault circuit interrupters, or of size are designed to protect against fires caused by arcing faults. Arcing faults can occur when damaged or worn wiring creates a spark that ignites nearby combustible materials. A size are required in many areas of the home, particularly in bedrooms. The electrical system in a home is a complex network of wires, circuits, and devices. It is important to understand the basics of how the system works and to take steps to ensure its safety. This includes avoiding overloading circuits, using properly sized fuses or circuit breakers, and regularly inspecting electrical wiring and devices. When dealing with electrical systems, it is always best to err on the side of caution. If you are unsure about something, consult a qualified electrician. Electrical work can be dangerous, and it is not worth risking your safety or the safety of your family. The information provided here is for general educational purposes only. It is not a substitute for professional electrical advice. Always consult a qualified electrician for any electrical work or concerns. In addition to the dangers of improper fuse replacement, there are other potential hazards associated with knob and tube wiring. This type of wiring typically lacks a ground wire, which can increase the risk of electrical shock. The insulation on knob and tube wiring can also deteriorate over time, creating a fire hazard. If you have knob and tube wiring in your home, it is important to have it inspected by a qualified electrician. They can assess the condition of the wiring and recommend the appropriate course of action. This may include replacing the wiring with a modern electrical system. Electrical safety is a shared responsibility. By taking the necessary precautions, you can help protect yourself and your family from electrical hazards. Remember to always consult a qualified electrician for any electrical work or concerns. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. It is updated every 3 years and provides detailed requirements for wiring, overcurrent protection, grounding, and other aspects of electrical safety. Adhering to the NEC is essential for ensuring the safety of electrical systems. Many local jurisdictions adopt the NEC as part of their building codes. This means that all electrical work must comply with the NEC in order to be approved. Electrical inspections are typically required for new construction and renovations. These inspections are conducted by qualified electrical inspectors who ensure that the electrical work meets the requirements of the NEC and other applicable codes. Electrical safety training is available for electricians and other professionals who work with electrical systems. This training covers topics such as electrical hazards, safe work practices, and the requirements of the NEC. Continuing education is also important for electricians to stay up to date on the latest changes to the NEC and other industry standards. There are many resources available to help you learn more about electrical safety. These include websites, books, and training courses. The Electrical Safety Foundation International, or ESFI, is a non-profit organization that provides electrical safety information and resources to the public. Remember, electrical safety is a critical aspect of home ownership and maintenance. By taking the necessary precautions and consulting a qualified electrician when needed, you can help protect yourself and your family from electrical hazards. The information presented here should be taken as guidelines and not be taken as advice for working with electricity. Electricity is extremely dangerous and lethal. Always contact a qualified professional to work with electricity. Electrical systems can range from 120 volts to 480 volts, and in some cases even higher. Working with any of these systems requires training and proper PPE of personal protective equipment. Improper use of tools, using the wrong PPE, or a general disregard for the hazards of electricity can result in severe injury or death. Any electrical work should be completed while the electrical system is de-energized. This is called lockout-tagout. The system should be locked out in such a way that no one can energize the system while the work is being performed. After the system has been locked out and tagged out, it should be tested to verify that it is in fact energized. The testing should be completed by a qualified individual using the proper PPE and tools. Once the system has been verified as de-energized, then work may begin. However, one should remain vigilant as there is always a possibility that something could have been missed. If anything seems amiss, then work should be stopped immediately and a qualified individual should be consulted. If the work has to be performed on an energized system, then even greater precautions must be taken. Only qualified individuals should perform work on energized systems. They should wear the proper PPE, including but not limited to a face shield, gloves, and insulated clothing. They should also use insulated tools. Before beginning work, they should inspect the area to identify any potential hazards. They should also develop a plan for how to safely perform the work. Work on energized systems should only be performed when absolutely necessary. There may be cases where it is simply not possible to de-energize the system. In these cases, it is important to take all necessary precautions to minimize the risk of injury. Remember, electricity is dangerous. Always take the necessary precautions to protect yourself and others. If you are not qualified to perform electrical work, then do not attempt to do so. Consult a qualified electrician. They will be able to safely and properly perform the work.